and upload it, but I don't know what's happening. You're welcome. With this one slide, this is just a little video that introduces homeostasis. So as you go through your notes, you're going to go ahead and write down, fill in the blanks for the notes. So I'm just going to show them as I go. The previous, if you needed to pause and go back to the previous slide, do that. For some reason, it went too fast. But some of the things you do when you're too cold is you shiver. And then some of the things that you do when you are hot is you sweat. This is your body going into homeostasis. Other things on your notes can do for homeostasis, some of the other things in your note boxes you want to put on the one side that asks what my body is doing. You want to put your body is shivering. When you're cold, how is this maintaining homeostasis? Your body's generating movement to warm you up. In addition to that, in that same box, what your body is doing, your body also has goosebumps. Putting a layer of fur. How is that maintaining homeostasis? Your body is trying to get you warm by putting a layer of fur covering on it. Now, going back to homeostasis, remember that is maintaining a balanced environment in your body. Moving down, how does your body regulate its internal environment through negative feedback and positive feedback? The fact that your body shivers when it's cold, that is negative feedback. It's fixing it. Another situation would be when your body is hot, then you sweat. That's your second box. That's also negative feedback. When something is wrong, your body has to fix it. Negative means wrong. So therefore you sweat. How is that maintaining homeostasis? Your body's trying to cool off by putting water on the skin. A third type that you want to fill in to the box would be something like going to the bathroom. When that happens, when you get your body gets too full of waste, then you need to release the waste. So what is your body doing? Your body's going to the bathroom. How is that maintaining homeostasis? It's getting rid of too much waste in the body or too much liquid. Pregnancy, when a woman is having a baby, the contractions that she's having is positive feedback because it needs to release that baby. So all of those contractions need to happen and even more to get rid of the baby. Moving down to the portion which talks about survival of organisms depends on homeostasis. Organisms can't live unless the concentration of substances stays within a specific range. If it's unbalanced and it stays unbalanced, organisms can die. If it's balanced, then that's how we thrive and how we live. Organisms function through chemical reactions occurring in the body. So reactions can only occur when conditions are right. So if the pH or the balance is right, then that's when the body can function. Right, review pH. What is pH? So pH is the measure of how acidic or how basic or alkaline something a solution is. So that's, you have the definition, you just have to fill in the word pH there. Now acids are going to range from 0 to 6.9. So you can put less than 7, but you also want to put 0 to 6.9. Some things that are acids are the things that are listed here, so pick a sample acid and put it on your paper. Bases or alkalinity, the bases are alkyne, those are going to be 7.1 and higher, because I'm 7.1 to 14 because it only goes to 14. But our these are some sample bases, so you want to put that in. Notice where blood is. Notice where saliva is. And saliva ranges between acidic and basic, but for the most part, it's a base. And then our middle part is 7, which is neutral, and that's our pure water. All right, so biological materials, those are materials that your body creates: blood, saliva, urine, all of those things within your body. So even if we change it small pH, it can harm the organism. So for example, pH of blood should be 7.4. Write that down. But
cause baby, now we got bad blood. You know we used to be bad
if the
love.
pH is
So
too
take
much,
a look what you've
this is an issue.
done. Cause baby, now we got bad blood. Hey, now we got problems.
If the pH
And
is
I
too
don't think we
high,
can solve
it could
them.
be
You
harmful.
made
But
a really deep
again, if it's too low, we can go back
cut.
to
And
the
baby,
videos
now
and
we
get
got
this out.
bad blood. Cause baby,
So some things that may change your pH. You want to pick one of these things that you identify with. Hopefully you do not identify with alcohol and drug use. But pick something within here that you can identify with and write down maybe 2 things that could change your body's pH. Maybe lack of exercise, maybe food coloring and preservatives. So those hot fries that you eat, that's strong food coloring to make those look red. That's red dye. Shallow breathing if you're not taking proper breaths when you're exercising, or overconsumption of foods that are high in acids or bases. So let's look into the paper and take a look at some of the foods that you may consume. Go ahead and jot down, let's say 5 foods that you consume, and go ahead and put it in that box. Pause the video so that you can jot down your 5 because I'm going to move on. Now, if you jotted down more things in this area, then that means that your foods are high in acidity. If you jotted down foods in this area, that means that you're in the area of high alkalinity or high bases. So what we did in class, actually did a demonstration, and we checked our pH of our saliva, and we checked to see it was where it was. It should be in the range in between. Your paper should have turned this color up to about this color. And they do this in the hospital when they check your urine, because your urine has a certain pH. Now, if when in class, if the saliva went more in here and more in here, it's because of something that's going on within your body, and it could be because of the things that you eat. Knowing that your consumption of food is either high in acid or high in base, how can you maintain homeostasis in your body's pH? Well, the answer would be eating a balanced diet. When we look at the slides or look at the foods, balanced diet means it has to have a balance of acidic food and a balance of basic food, or food that are high in alkaline, because then that balances everything out and neutralizes it. Remember, everything is for homeostasis. If you're having too many foods that's acidic, then you need to be able to eat some things that are alkalinic, like more vegetables. For that matter, that's why your parents want you to eat your vegetables. Some issues that can occur due to pH, there are several things, but one thing that we're going to look at is osteoporosis. Now, osteoporosis is actually caused by high-rich calcium foods or calcium-rich foods. So these are your milk, cheeses, dairy products. Overconsumption of this could be cause osteoporosis. Now, the first thing you think of when you think of bones is you think of strengthening your bones. So you have to have your dairy, or you have to have your calcium to strengthen your bones. But here's where the problem lies. So this is the why. First of all, in that area where you put osteoporosis, you want to put that is the weakening of the bone. Now here's what happens. Remember, it's all about maintaining homeostasis. So if we remember the previous slide we looked at, where do dairy products fall? They fall in the area of acidic foods. So overconsumption of dairy products, yes, you're getting the calcium to strengthen your bones, but overconsumption of the dairy products will increase the acidity in the body. Well, when your body's acidity is increased, then it's going to crave balance. So it's going to be looking for alkalinity. Now what happens is in your bones, you have the calcium that the milk has provided to you. That calcium is alkaline. It's a basic substance. So therefore, your blood is going to borrow the calcium from your bones. So now it's taking away what made your bones strong, and therefore that causes osteoporosis. So how should we prevent it? We should prevent this by again, having a well-balanced diet, not too much dairy. So some other issues, and you don't have to write these down, but you could if you're interested. These are other issues that could happen if the pH in your body changes. So again, we want to be balanced so that we don't encounter these issues. Now, changes in pH affects hormones, and it also affects the enzymes. The box that's underneath hormones, where you just wrote hormones, this is what we're going to write some information about that. So what happens is, before you eat, your body prepares you to eat. So when you're hungry and your stomach is growling, that's your body preparing, and it's preparing you by enlarging your stomach. And what's happening is the hormone gastrin, GASTRN, is being released in the stomach. That releasing of gastrin actually helps increase your stomach, so it stretches your stomach walls out so that when the food comes down, it fits in that space and it's then not stretching out then, so it provides a home for the food. Now, gastrin is in the lining of your stomach and in your small intestine, so your brain tells your stomach, go ahead and release that gastrin because food is about to come. So then what happens is when the food does get there, the gastrin is then also responsible for breaking, well, not necessarily breaking down the food, but getting rid of any waste products or any harmful, it disinfects, so it kills bacteria that enter the stomach with the food. So if you eat anything and it's some bacteria on it or whatever the case may be, your gastrin is going to help to disintegrate that and get rid of it. Now here's the problem. If your pH is off, then you could produce too much gastrin. Too much gastrin would be an overload or too high enlargement of your stomach, which means that you would cause your stomach to burst or create little holes, which are ulcers. Not they're very painful if you have holes in your stomach. The other thing, if there's too little gastrin, remember gastrin is also there to disintegrate, to get rid of bacteria. And if there's too little gastrin, then therefore you don't have gastrin, then you don't have you don't have what's needed to kill the bacteria with your food. So therefore, you can get sick. You can get an infection. Now, moving on to your enzymes. This should be a review. You should remember that if the pH changes with the enzyme, then it changes the fitting of the substrate and the enzyme. So it changes the shape, which means that now the enzyme becomes ineffective. So that's this here. Acid-base regulation, because we are not perfect, then our body regulates, it controls when acids and bases come in. So it maintains an acceptable pH range in our extracellular fluids. Those are the fluids that are all around our cells. It maintains a acceptable amount. So too many acids come in, it's going to counteract it with bases. Too many bases come in, it's going to counteract it with acid. And the way it does that is with something that's called a buffer. Now in your next line next to buffer, buffers provide an immediate response to fluctuating pH. So if the pH is off, then your buffer is going to provide immediate response. Think about your YouTube video. When it's buffering, it's fixing so that it gives a full movie. Now your buffers are solutions that resist change when acids and bases are increased. The word increase should be here, or added, which is like what's in your note. And then this is not in your notes, but this information is good. pH buffers are in your blood to guard against any sudden changes in your blood becoming too acidic. They're also worked chemically to minimize change in the pH solution. So looking here, your body's buffering. On your paper, you want to make sure yours says lungs remove CO2, kidneys remove HCO3, which is a bicarbonate. Don't really need to know exactly what that is. And then you have your heart rate hinders CO2 removal there. So explaining buffering. What happens is when you exercise, your lungs are already working. And so they are working to remove the carbon dioxide that you take in when you breathe in. But your heart is working really fast as well. And when your heart rate speeds up, that stops the removal of CO2 because now you're not taking full breaths, you're breathing too fast. Now your kidneys are going to remove the HCO3, which is a bicarbonate. So what happens is removing CO2 from the blood helps increase the pH level. So when the lungs remove the CO2, your pH is going to increase, but then your kidneys are going to remove the bicarbonate, the HCO3, and removing the bicarbonates helps lower the pH. So these two things working together keeps maintaining balance. Increased pH increases acidity. Decreasing pH, lowering pH increases basicness. So that's going to be things that happen every day is when you get a stomach ache, you're taking an acid or an Alka-Seltzer. Notice the word alka, from alkaline. It's basic. So your stomach pain is from an increase of acid in there. So you take an Alka-Seltzer that balances out the acid with the base, and it helps neutralize your stomach. So then lastly, check understanding. How do biological materials use buffering to respond to an increase of acids and bases? Remember, if your body has too much acids, what's going to happen? It's going to do something to provide a base to counteract it, and vice versa. If your body has too much base, then it's going to do something to counteract it with acid. So therefore, biological materials will have some buffering ability, because being able to regulate pH levels is important for living things to be able to survive. So it's all that one thing. So overall buffering is the process used for your body to do what? Going all the way back to what we've been talking about, maintaining homeostasis. And this ends our slideshow.